Hello friends, in today's class we will talk about simple tokens and their finite state machine model. Okay, after discussing all this, few I'll say not in detail but few examples of FSM regular expression. Now we can see here that how actually this is useful in generating lexical tokens. Okay, so now for generating lexical token, how we can use the finite automata. So few example not related with any language, but just it will give you the idea or just a hint about how these are actually implemented. So here we have like if you want to recognize the lexically you want to recognize if, then you must have a state that is doing transition from 1 to 2 on input I and then F. And once you are here, then you can determine this that this is a token if. Identifier should begin with like underscore. Look, this diagram doesn't care of that. So here the definition is begin with the alphabet followed by digit. Okay, so this is your identifier. Begin with alphabet followed by digit or alphabet. So that capture this this diagram capture that this is an ID. If you want underscore to be included over here, then you can put simple a dash here, and that will be sufficient for that definition. Number begins with let's say a numeric value, decimal value begins with the 1, like 1 followed by it can be again 1 and 2 or a 9. Okay, so this is a number, and that if you are here with this scanning of numbers, then I will treat that token as a number token. Real number can be something like 0 1 2 3 0.6 164. So 0 or 9 it begin with, and then we can repeat 0 or 9, and then there will be a decimal radix point followed by 0 or 9. Here 0 is not mandatory to include, but as per the situation you can change it to, let's say if you want 1 to 9, then you can also write here 1 to 9. Otherwise you can just start with a decimal radix point and then followed by 0 to 9, and then you can repeat 0 to 9, and that number will become a real number. So these are the few examples this how the lexical tokens are recognized by using finite state machine. Okay, so the machine model that we learned here is DFA and NFA. Regular expression, I will say that this is let me just write 1 to 9, and then I'll say that 1 to 9, or you can write 1 plus 2 plus 3 up to 9 and any number of times. Okay, so that is a few example. And if we have a regular expression as only a single atomic value, that is if. So that is how the lexical tokens are recognized by using finite automata. We have a tool that is called lex, and in lex you can specify the pattern, and output for this is basically a C file. Okay, so that can help. Okay, so that's all for this session. This is the few example we learned about this finite automata for the lexical token. So that's all for this section. Thank you.